So this is part 2 of 4.1. Last prep questions, number 6. And it's talking about two different types of wood chippers. So the first thing that we want to do is determine what our variables are. And usually in the problem it will tell you what they're trying to find. And here it says the number of each type of wood chipper. So we're going to say that deluxe, that X equals the number of deluxe wood chippers. And Y is going to equal the number of economy wood chippers. Now pick out your totals. What totals? This is talking about 3 hours to do something. This is talking about a half hour to do something. But this says the maximum number of assembly hours is 24. So 24 is the maximum. So that means that whatever is less than or equal to 24. And then we have, and this is assembly. And then we have painting hours, and it says the maximum for that is 8 hours. So whatever hours has to be less than or equal to 8. And this is paint. So then it goes up here and says the deluxe model takes 3 hours to assemble. So that's 3 hours per deluxe model, so 3 times X. And a half hour to paint. So I've got to put that down here in my paint, and so that's 1/2 times the number of wood chippers, or X. And then we're going to add to that the economy models, and this takes 2 hours to assemble, so that's 2 times Y, and 1 hour to paint, so it has to go in paint, so 1 times paint, or 1 times Y. Now we also have to give it to give X some limits. Well, X has to be greater than or equal to 0 because you can't make a negative number of wood chippers. Y has to be greater than or equal to 0 because you can't make negative number of wood chippers. So here are the inequalities. It says write the system of inequalities that describes the constraints on the number of each type of wood chipper produced. So that's what we did here. It gives us a graph down below, so we're going to go ahead and graph them and find the corners again like we did above. So first off, we want to get the best thing to do is to use intercepts. So X equal to 0, Y is going to be 12. If Y equals 0, divide by 3, X is going to be 8. And so for this one, I tried to change colors, but it didn't happen. So this one, if X is 0, then Y is 8. If Y is 0, then X is 16. So we're going to graph these down here. So we're going to get rid of some of these markings. Just a little bit more. So the first thing that I'm going to graph is X is equal to 0. Again, I'm going to use this as my 0, 0. So this is X equal to 0. And it says greater than, so I would be looking at this side of the shading. This is Y 0, so that's a horizontal line, and it says greater than, so I'm looking at this side of the shading. going to graph this one. 0, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 8, 0, 1, 2, 3, 4, 5, 6, 7, 8. It's a solid line. And it says it's less than, so it's this side of the line. Alright. Now I'm going to graph this one. 0, 8, 1, 2, 3, 4, 5, 6, 7, 8. 16, 0. So this was 8, 9, 10, 11, 12, 13, 14, 15, about right here. Solid line. And it says less than, so it would be this side. So we see that this is where everything is shaded. And let's find the corners. So here's a corner, which would be 0, 0. Here's a corner, which is 0, 8. Here's a corner, which is 8, 0. And then we have this corner, which is the intersection of these two. So, unless you like to do substitution or elimination, the easiest way is to do the inverse matrix, or the RREF. So I'm going to put it in my calculator. Second matrix, edit. It is a 2 by 3. Two, 24, 3 to 24.5, or 1/2, either way. It'll take it. 1 divided by 2, or 1/2. I mean, or 0.5. 1, 8. And then I'll move this up a little bit. I'm not sure what all this stuff is. Oh, where'd it go? So then we're going to go home, second mode. I don't know what's going on. Second matrix. Math. Nope. Second matrix. Math. RREF. Second matrix A. And we can see that x equals 4, y equals 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Yes, I would agree with that. And so that would be all of our corners. And like I said, eventually we are going to do something with those corners. This is the start of what we call linear programming. So this is the end of 4.1. If you have any questions, write them down and bring them to class with you.